All right, we're still on 5B. We're going to go through a couple examples. So I'm looking at example 2. And it says find the amplitude and period of the function y equals 2 sine of 2x and sketch its graph. So the first thing that I notice is now we have a sine curve. So if you wanted to start by graphing your original parent graph, you could. I'm going to actually fill in this stuff first. So I'm going to label what I know. I know that my A is 2 and my K is 2. So my amplitude is going to change and I do have a period change. So my amplitude is the absolute value of A, so the absolute value of 2 is still 2. And I want to do 2 pi over K, so 2 pi over 2. I can simplify that fraction, so I'm going to. My 2's would end up canceling and I would just get pi. So if my normal period is 2 pi and now my period is pi, I'm still like squishing it, so it's gonna appear squished. So I'm gonna fill in this table first. So I'm dividing each x coordinate by k, and we said k was 2. So I am dividing by 2, or I can multiply by 1/2. Those are mathematically equivalent. So to start, I have x. So I'm going to take my 0, my x coordinate, and I'm going to divide it by k. So I'm going to divide it by 2. 0 divided by 2 is still 0. So that one does not move. Hold on. My red pen works. Then I have pi over 2. Since this is a fraction, I'm going to do the multiply by 1/2. I apologize for my cat, if you heard that. When I do that, I multiply straight across, so I have pi over 4. That is already simplified. Then I have pi. Since that is not a fraction, I'm just doing the divided by 2 option, so that gives me still just pi over 2. Then I have 3 pi over 2. Since that is a fraction, I'm multiplying by 1/2. And I get 3 pi over 4. And then 2 pi. I'm going to also multiply by half. You would end up with 2 pi over 2. Simplify it down, you get pi. So I'm actually going to start with graphing my basic original curve for sine of x. So if my amplitude was not 2 and if my k was not 2, I'm going to start with that. So I need a scale on my y-axis. Since my amplitude is 2, I'm only going to go up to 2 because we haven't talked about vertical shifts yet. So it's not like it's going to get shift higher or lower than like 2 or -2. So this works. So my original sine curve, I know it starts at my origin. For pi over 2, I'm at 1. And back to my origin. 3 pi over 2, I'm at -1. And then there. So I have this curve. So I have y equals sine of x. That is my original curve before the period change and before my amplitude change. So I'm going to do this one a little different than I did in example 1 in the other video. I'm going to do the period change first, and then I'm going to change the amplitude in 2 separate steps. In the last video, I did it all in 1 step, but I want to show you that you could do it like this as well. So I'm going to do a different color. So I'm actually going to do green for, well, I'll do red for my period change. So right now all I'm doing is I'm going to be taking my existing points that were at these and I'm shifting them to be at these x values, and then I'll worry about the amplitude next. So the point that's at 0 is going to stay at 0, nothing happens. It stays there. The point that was at pi over 2 was this one, and I am shifting it to pi over 4. So this point is getting shifted to about right here. Pi over 4. So I have 2 points. I do have this one, you just can't see. My next point was at pi, and I'm shifting it to pi over 2. So this point was at pi, and I'm shifting it to here at pi over 2. Then I have 3 pi over 2, 3 pi over 2, and I'm shifting it to 3 pi over 4. So I'm going to go straight across. Also realize that might not be at -1, but it's okay. It's an estimate. It's a quick sketch. Check that one off my list. And then my very last one is 2 pi, and I am shifting it to pi. So I can see my curve here, so I'm going to go ahead and connect those. And it still looks like a sine curve. It's just a little bit smaller. So this one, I'm going to make a note, has the period change, but we still need to change the amplitude. So if you needed to do it in multiple steps, you can. If you want to do it in the same step, you can. So I know my amplitude is 2. Any point that's on my x-axis is going to stay on my x-axis. It's like a rubber band is being held here and I'm stretching it vertically, and then it's still being held on the x-axis and I'm stretching it down as well. So those will not change. This point, instead of being at 1, since my y value is 1, I would multiply that by my amplitude, which is 2. Well, 1 times 2 is 2, so I'm just going to shift that point up to 2. This point, the y value is 0, so it stays at 0. This point, my y value should be -1. It looks like it's a little bit lower. -1 multiplied by my amplitude would give me -2. So that shifts a little bit like that. And then this one doesn't move because it's on the x-axis. So I'm connecting this point with this, and then this point here, and this point. So for my final curve with the period change and the amplitude change, it would look something like this, where the blue is my final. So you can see the progression from the original. We did a period change and squished it, and then we changed our amplitude and stretched it vertically. So I'm going to label this as my final, and the blue graph is my final. On your test, I will need you to label whatever one your final curve is so I know which one I'm looking at, especially if you show multiple. If you only show one curve, then I'll just grade the one curve, but if you're doing the original and then you're moving it, I need you to label it. All right, we're going to keep going. So for example 3, this one's a little different because if you'll notice, we do have a fraction now in the equation. So I'm looking at y equals 4 cosine of 1/3 x. So I'm still doing the same thing. I'm finding my amplitude and my period, and I'm sketching the curve. So this is a cosine graph. I have my a and my k, so if I want to label those, I can. This is my k. This is my a. So my amplitude is 4. My period is 2 pi divided by my k, which is 1/3. That looks really weird, so I can rewrite that. If I'm dividing by a fraction, that is the same thing as multiplying by the reciprocal. So instead of dividing by 1/3, I can multiply by 3. So my period will end up being 6 pi. So if you'll notice on our graph here, it's a little different. We do have numbers on our y-axis, and our graph does go to 6 pi. Normally, a period just goes to 2 pi, so 2 pi is right here. So if this is our normal curve, we're actually stretching it out this way, where example 1 and example 2 squished them. I also gave you this graph because I will give you the x values that you need. There should never be a point where you're like adding your own tick marks because that gets too messy and it's a little complicated. So I'm going to start by dividing each of my x values here by my k. So I am dividing by 1/3, or I can multiply by the reciprocal, which is 3/1, which is just 3. So of these two options, multiplying by 3 is definitely the better of the two, and I'm going to do that for all of them. So I'm going to take my x value, and I'm going to multiply by 3 here, and I still have 0, so that one doesn't move. My next x value is pi/2. I'm multiplying that by 3, which is technically the 3/1. So I get 3 pi/2. Next I have pi, and I'm multiplying that by 3, so that is just 3 pi. Then I have 3 pi/2, multiplying that by 3, so I get 9 pi/2. And then 2 pi. So I have my new x values for the period change, and I'm going to go ahead and sketch my basic cosine curve first. So this is a little tricky because since these are different, you want to make sure that you have a really good understanding of what a cosine curve is. So cosine starts at 1, for pi/2 we're at 0, pi we're at -1, and then we're back up to +1 for 2 pi. So this is our cosine curve, looks like a U. And I'm just going to label it original. And then for this example, I am going to do the period change and the amplitude all in one again. So my point here, my point that is at my x value of 0, which is this one, is not getting shifted at all because it's still ending up at 0, but my amplitude will change. If the y value of this is 1, I multiply that by my amplitude, which is 4. So this point will actually end up here at +4. We graphed our first point. For my second point, I'm at pi/2, so this point, and it's getting shifted to 3 pi/2. So this point here is actually shifting over here. It's a little confusing because there's already a point there. And then because the y value of that point is 0, the amplitude does not affect it. So I'm there next. Check it off my list. The point that is at pi is getting shifted to 3 pi. So I'm going to shift this all the way over here. This is where 3 pi is. But with my amplitude, I'm not at -1 anymore. Now, if I multiply -1 by my amplitude, I would end up at -4. So I'm actually going to put my point down here at -4. Check that off my list. 3 pi/2. So the point at 3 pi/2 was this orange one that's underneath that blue there. It's getting shifted to 9 pi/2, which is here. Because it's on the x-axis, it stays on the x-axis. And then my last point that was at 2 pi is getting shifted to 6 pi. So all the way over to 6 pi. And then the amplitude changes the y value from 1 to a +4. So I can connect these, and I want to make sure that I still have curves between them. I don't want like straight angles that look like triangle corners. And this is my final. I hope those examples end up helping a little bit.